Hello, good afternoon, everyone. It's really a pleasure to come back again because I think I presented 2 years ago in the same forum. Actually, by seeing the forum in different years, I can really see the difference of the industrial focus. For example, 2 years ago, we had a lot of discussion on silicon carbide for automotive. How can Taiwan ramp up the production? And right now, we are moving to more like AI application driven regarding the ecosystem. So I would say for compound semi, we have a lot of possibility to cover different applications. And today, I'm also very glad, for example, in the morning session, in the afternoon session, we have different speakers covering different materials, different applications. So I think it's also maybe my turn to also share some insights from you. So basically, the topic is compound semiconductor as a key enabler for the AI era. But I think from our maybe personal experience, so I would say maybe in my generation, and I would say very likely even today, when we need to find some information, we just Google and to search the information, try to figure out what will be the answer. But apparently today we have a lot of these kind of like AI platform agents can really help you to build the article, can really give you the answers. Even, for example, when you are traveling, you can ask the AI tools to give you like agenda for your trip maybe to France, for example. So it's really this kind of a capability provided by the AI data center. So it's really the market driver and what is really behind, for example, the AI revolution with the machine learning, with a large language model, this kind of a lot of consumption on data, on power is really driving the demand. And then, of course, we have the crypto, we have the Bitcoin, this kind of like also very emerging, a lot of demand. For example, from what I seen, you can right now purchase a flight tickets with the Bitcoin if you have accounts. And also the e-commerce, like in Taiwan, we also have a lot of these kind of new platform provide you the new type of commerce. You can purchase anything you want. And then, of course, the digitalization, smart home, a lot of new features. Video, I believe many of them, you are really watching the stream on the internet. And also, probably also the case in Taiwan, people are doing home office. And then you have the social media and also 5G IoT. So all in all, you have a lot of real demands around the daily life purpose. And behind that, it's really the data center. So I think we have seen similar type of like the rack today. So we have, and this kind of configuration, you have the switch, you have the computing server, you have the storage, and then you have the PSU, different type of system or subsystem in the rack. So as today, we are mainly talking about compound semi. So what will be the positions of compound semi to be used in the rack? So in the PSU, for example, I put some examples here. We have the silicon MOSFETs. We also have the wide bandgap can be used. So these kind of applications is really the entry point for the wide bandgap silicon carbide gallium nitride. We have heard a lot of examples in the previous presentations. And then another very important subsystem will be the interconnection. So for example, here, I also put, for example, you have the PIC, you have different like VCSEL, even for example, micro LED is also mentioned today that it can be one of the key components in the rack, in the AI data center. So to have the really the benefit from the compound semiconductor, for power, you have higher power level, higher power density, higher efficiency. This is really driving the demand of the power electronics. And then for the photonics, you have the high data rates and to have like low latency and also lower power consumption. So I will consider when we talk about compound semiconductor in AI data center, this will be the key positions of the technologies. So maybe let's start with power by seeing the wide bandgap semiconductors in the AI data center. So let me start with some news. So I would say from the past year, actually 2025, we have seen already a lot of partnerships led by NVIDIA. So NVIDIA has built this kind of partnership with different companies for cooling, for infrastructure, for power supply units, and also with their customers. But actually, at the same time, we have seen the partnerships across power electronics. We have Infineon, Navitas, TI, ROHM, onsemi, and also Innoscience. So we believe there will be more companies. They will have the partnership with the ecosystem around NVIDIA. But somehow, it's also interesting to look at what would be the technologies they have. So of course, besides silicon is very essential, very important technology. But when we look at what would be the technologies those power electronics companies they have, for example, Infineon, they have both silicon carbide gallium nitride, the same case for Navitas, for ROHM. But when we look at TI, onsemi, or Innoscience, they also have the wide bandgap technology. So I would say in general, for the power electronics with wide bandgap, it's really the important competence to build the next generation of the power supply for AI data center. So I would say we have seen this architecture today for a couple times. So from the grids, we have the UPS, the PDU to the PSU to the low voltage parts, and then to feed, of course, the very like power hunger, the GPU. So you will consume kilowatts of the power. So what would be the actual positions of wide bandgap semiconductors? So when we look at silicon carbide, if we are looking at the actual or the current solution, so silicon carbide is more for the AC/DC stage. So in this case, many companies, they have 650 volt device. Infineon also launched the 400 volts silicon carbide MOSFET device. It's quite suitable for this application. So for the moment, I would say silicon carbide is well positioned, especially for the fast switching leg in the AC/DC stage. But on the other hand, gallium nitride today, we have heard that we have seen a lot of presentations to talk about the potential of gallium nitride. So gallium nitride, today we see more the DC/DC stage, no matter it's in PSU or in the IBC to the low voltage. So it means it can cover from, in terms of the device voltage rating, from 650 volts to the low voltage, 100, even 40 volts voltage rating by using the gallium nitride technology. So the idea is also to see the next generation of the PSU or the power supply of the very power consuming GPU or computing rack. So for gallium nitride, we see more potential to enter the higher voltage, even to the AC/DC stage. And also, we have a lot of projects ongoing by different players. It's really to go to the low voltage. So in the future, there will be also the next generation to really decrease the steps or the stages of the architecture, because it will be a very effective way to decrease the stages and also to decrease the power losses. So overall, the added value of the wide bandgap technology, as you can see on the slide. So higher power, lower form factor, more compact system, and also high efficiency. And of course, there will be also like some value proposition in terms of the company. For example, if they want to decrease CapEx or OpEx by using this kind of technology, and also to decrease the carbon footprint. So overall, that's why we consider this is the strong position of wide bandgap in this case of an AI data center. So when we look at a little bit the history, so how silicon carbide became the, let's say, mainstream technology from the beginning. It started maybe 20 years ago, and right now, for example, even like in Taiwan, in the road, you can already see a lot of silicon carbide-based BEV. For example, you have Tesla, you have a Hyundai, you have a Kia, a lot of cars. So how it started? So in the beginning, maybe the penetration is not like very quick, but we know that it's because of Tesla. They introduced the silicon carbide-based inverter starting in 2017. Since then, we have a very strong increase of the demand. Even, for example, in, I would say 2023-24, the discussion was very, very hot, and you also drive the demand, the supply to another level. So of course, today we have some discussion on there will be some oversupply, but overall, with this Tesla effect, we have seen the acceleration of the silicon carbide technology. But on the other hand, because at Yole, we also have the forecast of the gallium nitride technology. So in the previous years, we consider gallium nitride will grow, especially driven by consumer, but right now, also with automotive. But right now, because of this AI data center, so it will be also it could be also the case that gallium nitride, the development, the business will be accelerated in the next years. So I would say it's also quite important. Let's also quantify a little bit what will be the market size of the wide bandgap technology in terms of silicon carbide gallium nitride, because we have a lot of different discussions on, okay, two technologies will also, both of them, they will take a big market, but how big? So according to our studies, so we publish these reports, the power electronics for data center 2025. So in the work, in the reports, for example, here I'm showing you the market forecast in terms of the market size for silicon carbide, and the gallium nitride in the AI data center applications. So overall, like I mentioned in the previous slide, so silicon carbide mainly using AC/DC stage of the PSU. So we see the growth of the markets, but somehow if you compare with the gallium nitride one, so I would say gallium nitride, the growth, the market size will be more impressive, and there will be some reasons behind to drive the growth. So for example, the 650 volt device is ready, and then we have seen the development of the 40 volt to 100 volt device, and then we have seen the bidirectional systems devices, and then to enable the next generation of a PSU. So that's our view on the power electronics. But somehow in the ecosystem, something might be changed as well. So for example, as of today in 2025, fabless, foundry, they are taking really large parts of the business. Of course, one of the reasons is because of TSMC is the biggest foundry for gallium nitride. But as the company decided to quit this market, and it will of course release 40% of the market. So as of today, we have seen different players like Vanguard, Global Foundries, PSMC, Tower Semi in the US, for example. They are entering the market by having the 200 millimeter platform, fully depreciated, more semi-standard production line. So in the future, we consider that could be the case. So IDMs, they will in short term take more business, because when the foundry release a large part of the market share, IDM right now is more catching up to build their own internal capacity. And then it could be also the potential merger acquisition of fab-like companies. But in long term, because of the join of the new foundry players, we have another balance in terms of the market share. So that could be also the view of the market in the next years. And if we move on with the photonics, we also consider a very important one. So let's zoom in a little bit in the rack. So during the day, we have heard different way of scale. So scale up, scale out. So by looking at the trends, maybe I'll put it this way. So the idea is to go for higher density in terms of the optical interconnects. So the idea is to have stronger or the higher scale of the data transmission by using different solutions. So it could be the discrete device, or it could be silicon photonics if we look at more the device perspective. But of course, when you look at different type of systems or the modules, we will have the pluggables, or we have the CPO. And CPO, again, they can have the scale out, scale up, different type of way. And there are some details I listed in the slides in terms of a cost, in terms of reliability. So of course, there will be pros and cons. So the idea is to show we will have the two type of the systems or the subsystems in terms of it will be more discrete based, or there will be a higher level of integration. But as today, I consider our forum is more related to compound. So if, again, we look at the level of photonics, gallium arsenide VCSELs, some speakers mentioned it earlier today. So to build high data rate VCSELs, for the moment we consider 200 giga per lambda seems in the short term there will be the solution. But somehow, of course, the industry, the ecosystem is asking for higher data rates. So at the same time, we have this kind of indium phosphide continuous wave DFB laser solution based on the silicon peak. And then to move on to the next generation of the heterogeneous integration. For example, there's a forum yesterday to talk about it. But it really depends on the cost or how the technology can be developed. So if we consider different scenarios in the industry, maybe gallium arsenide VCSELs will come back with the cost competitive 200 giga per lambda solution, even to 400 giga per lambda. So they could lead to this kind of position of this technology. It will be very cost competitive, and it's quite mature. So somehow we consider it's one of the potential mainstream technology for the photonics. And because of the challenges or the yields, as of today, we also have seen this kind of thin field lithium nanobates as the modulator under development. So if the yields will be very challenging for this peak, then maybe we will have the winner also based on this lithium niobate solution. But somehow at the same time, we also have the indium phosphide EML to reach the 400 giga per lambda. For the moment, we consider there are some challenges to be overcome. So overall, the takeaway of this slide is to see a lot of demands is really driving the innovation, and we have different platforms, different modulator type of materials, and the innovation is ongoing on different type of the platforms. So maybe again to focus on the photonics based on the compound semiconductor, by taking the example of gallium arsenide. In the past years, it's driven by either datacom, either the 3D sensing based on the smartphone, and also the micro LED. Right now, we have seen already the 8-inch platform. It's already available on the market. And what will be the case for indium phosphide? Because if indium phosphide will have, again, very strong demands, we also see the momentum for the 3-inch platform to the 6-inch platform. So actually, it's really the demand driving the volume and to create this kind of new movements in the ecosystem. So if we put together many factors at the same time. So driven by the market, and then also regarding the request of the very cost competitive solution. So the platform from 3-inch to 6-inch. And then regarding the device size, we have the DML, EML, even to the peak, we will see larger and larger devices in the future. It's also another synergy to really match the benefits of moving to 6-inch platform. And of course, at the same time, in terms of substrates, we have multiple suppliers. They can provide decent quality of the 6-inch wafers. So that's why overall, there will be the photonics parts when we are talking about the AI booming in general. So before jumping into the conclusion, maybe I'll take this one just to show our view regarding on the compound semi market. So actually today I would say all the market has been addressed by different speakers today. So I just highlight let's say the fast-growing markets or the key markets I mentioned today. So gallium nitride for power device, very high growth rates. Even by 2030, we consider the markets will be the level of 2.5 billion. In terms of silicon carbide, it's well, AI data center is a smaller market for this technology, but somehow it's part of the 10 billion market by 2030. At the same time, indium phosphide, the demands will grow as well, and will also create a growth rate more than 10%. And of course, if we look at the entire compound semi ecosystem, in general, we see the growth on, in general, all the applications. So if I conclude my speech today with this slide, so overall by 2030, like I just mentioned, overall compound semi will reach around 25 billion, and AI and also the data center demand is one of the market driver for this market. And then because of the high power consumption and also the request of a high power conversion efficiency, so wide bandgap technology is a very good solution, especially the gallium nitride, to have a higher growth rate. And also if you look at the business or the ecosystem, one important foundry decided to drop, so a lot of new opportunities for different foundries to enter. And when we talk about the photonics, very high demand, and we also have the new kind of technology. For example, the CPO is also a very hot topic in recent days. And all the strong demand is really driving the evolution of the technology. For example, the 6-inch indium phosphide will be the case in the next years. So thank you for your attention, and I'll be very happy if you have any question I can answer. Thank you.
Any questions? Please.
Hi, thanks for a nice talk. And I think that everybody knows that NVIDIA told us that silicon carbide in the process may be a potential applications. And can you comment about this news? Thank you.
Yeah, so I'll say that there will be the recent news, right? Like many people are discussing on this topic. So maybe I'll put it this way from the silicon carbide ecosystem itself. So for the moment, we have a lot of discussion on the oversupply of substrates, especially from China. So they need to find a way to solve the capacity issue. So recently, we have the AR/VR glasses by using the silicon carbide lens and also this interposer. So it's really built on the capacity and also the 12-inch capability. So I would say this is one of the potential application for silicon carbide, but somehow it's really built on the accessible 12-inch silicon carbide wafer, and it's ongoing today. But of course, in the end, it depends on if the companies want to take the solution. But I would say for R&D, it's a very interesting approach.
Okay, thank you.
Okay, let's end. Okay, Larry.
Your game, projection forecasting. Do you think like a 40 volt or 100 volt by directional market can be large enough to overtake 50 volt in the commercial application. How do you think about that? Or, the previous promise maybe is just a dream.
Bidirectional.
Bidirectional.
Yeah. So we see the development for both low voltage and medium voltage. So the idea is to have this technology ready, and then, like I just mentioned, it's really to see the potential of the next generation of the architecture. So I would say from device manufacturers, is try to get ready, and then depends on the collaboration with the system players. So I would say it'll be hard to say if it will be the important or the biggest part of the market. I think it's a little bit early to say, but I would say we see the potential.